Okay, hello everyone. Today we will be going through the day 2 of the AP Chemistry. Today we learn about the Hess's law. It states that if you know certain chemical reaction, and then you can actually combine those two and get a new equation and find the new delta H. Yeah. Delta H for any reaction can be written in step equal to the sum of the value for each individual steps. Let's take a look at this one. So basically we want to find the formation equation. So remember that the formation equation requires this coefficient to be 1 mole of the product is being produced, and we are just going to have each element and we put the coefficient and we get this, and yeah, we plug in this. Okay, and we're also going to plug in this. Okay, we plug in this and we also plug in this. Yeah, we just add those two and we get the final delta H. Okay, and this is just another example. We'll do some example in the end. So yeah, this is just another example. And there's another one. So this is the calculate the heat of reaction delta H from enthalpy of formation using the table of enthalpy. This is deriving from the Hess's law using this table over here. Yeah, it's this one, right? I think it's this one. Just give me a second here. Okay, yes, there's another one here. So we're gonna use this table. We know the formation of each compound element, and we know the enthalpy, and we can for those compound element, if we don't see them in the end, like this one, the methane, we're gonna decompose. Okay, we're gonna we're gonna do a decomposition, and we will have the opposite amount of the delta H here. For example, methane, originally if we want to form it, it requires negative 74 kilojoules. However, since we are doing the decomposition, we're gonna have positive 74 kilojoules. And if any element that's being formed like this one, we're gonna take the value here, like the carbon here. We're gonna take where's CO2 here. And another thing here is that they have different states. For example, this one, the water, liquid, gas, they are kind of different, so just be careful with that. Okay. And yeah, and we can just get a final enthalpy. Any element that's being formed, any element that's being formed like this one, yeah, you're gonna take this, and don't forget to multiply the coefficient. And the third method to calculate the enthalpy is through the bounding. Well, for example, this one. This is the original bounding, okay, and we also have a BRH bound, but in the end this is how our diagram is going to be looking like. So what we have here is we remove a double bond here and we add a single bond between carbon and carbon. And we also add this CH bond here. We also have this CBr bond. And we're gonna subtract the energy that's being released for making those bonds and adding those that's required to break the bond. And HBr, it originally have a HBr bond and we decompose it and we break it, so we can add that. Okay, we add this and we add this and we subtract those new bonds that's being formed, and that's the third way to calculate the enthalpy. Okay, that's pretty much it, like the second day what we learned. Let's try some questions. Okay, let's do this one. Okay, there's 3 different equations. I need to determine this reaction. Well, this is going to be our target, and this thing can only be formed with this thing here. Okay, we can only obtain this from equation number 3. Therefore, we're gonna reverse it. Okay, as we reverse the reaction, the delta H is also going to be reversed. So we will have, let's label them first. So negative reaction number 3, and since we want this thing here, we're also going to add this, so we're gonna reverse it, and delta H is going to be negative, so we're gonna also reverse number 2. And let's put the equation on our notebook, because it's going to get very messy soon. So far, this is what we have, and we also going to add this thing here. Oh, sorry, we don't need to reverse it. This is already on this side. My bad. Okay, we're gonna add this. 2 plus 2H2O. But 4O2. Okay, let's cancel out those waters here. Let's cancel out those water here. And let's cancel out those oxygen. There's 1 oxygen left, okay. And let's cancel out this carbon. It looks like we have this. Okay. And obviously we don't. Wait, did I do something wrong here? I don't think so. I don't think so, right? Wait, I might did something stupid here. Wait, there's 3 carbon here. Why did I? Oh, okay, yeah, there's no carbon here, sorry. Okay. Okay, there should be 2 water here instead. What am I doing? Okay, there should be 2 water here. There should be 2 water here, my bad. and here we're gonna try to get the hydrogen, and we can just simply add this equation here. We can add number 1 and we get, okay, we cancel out those two H2O and we cancel out the O. Okay. Oh. And we bring the H2. Okay, that's how we get the answer. And let's do some calculation here. 2. And subtract this. Okay. Okay. Okay, around this number. Okay, that's how we get the answer for this one. Yeah, do we have answers for this one? No. Okay. Okay, that's fine. And let's take a look at this question here. We're gonna use the table of enthalpy. We're gonna use this one. So NH3, we break it, right? So that require energy, so we plus the value of NH3, the form. Wait, hold on, this is from the table of enthalpy. Yeah. Okay, let me looking for NH3. Okay, negative 46 and plus oxygen. No, this one is already the element, so we don't care about this. And this thing is the things that's being formed, so we're gonna subtract whatever energy in O2. Okay, the 33. Okay, 33, and this thing, water, this is a gas, okay, so be careful. This is, we're gonna subtract 3/2, whatever water, formation of water, the energy required, okay. Gas, okay, this water is gas, so negative 241. And let's calculate it. Huh, interesting. I get different answer. I don't know, for some reason I get 280 joules. 282 joules. Very weird. I think. Wait, what? Wait, did I mess up? Oh yeah. This forming we gonna add. Never mind. And this breaking is going to be negative. So. Okay, my bad. Okay. Now we calculate it. Now we get negative. Okay, never mind. This is my bad. Okay. CaO. That's going to be breaking. So we're gonna take the opposite of formation. Okay, I cannot find it for some reason. Let's skip this one. I cannot find the value for this. Okay, let's take a look at this one. Okay, this one 46. We just multiply this by 2, okay. And this thing here, N2O. Okay, we take the opposite. Okay, N2O. 82, and this is the composition, so we're gonna subtract this. And this one is formation. This one is pure element. We don't care about this. And this is water. We're gonna plus 3 times whatever the number. I think we already get water, right? So this is negative 241. Let's check the answer. 2 times 46 divided by 3 times 82. Subtract 3 times 241. Yeah, I get negative 877. Okay. Nice. And let's do this one. Calculate the bounding, so the bounding should not be too hard, right? So mathing, it should be this, right? I think it should be this. O2. Oh, I think this is single bound, I guess. And CO2, I don't know, something like this, I guess. We don't have the answer to check. Maybe we should leave it for next time, alright? And yeah, this is pretty much for this video. Thank you for watching and see you in the next one.